This is the first of 3 tutorials looking at simultaneous equations. The simultaneous equations come as a pair of equations, and in our case 2 variables x and y. We can have different number of x's, different number of y's, and the constants at the end can change as well. We're setting our equations up so that we have the x's lined up, the y's lined up, the constants lined up at the end as well. We're going to call the type 1 equations equations where we have the same number of y's but the signs are different. And in the example I give you here, we've got plus 4y's and minus 4y's. So what method do we go through when we try and solve a pair of simultaneous equations? Well, for type 1, we do the same thing over and over again. So the first thing we do is we add the equations together, because that will cancel out the y terms. Then we solve for x, because all we'll have is an equation in x. Then we substitute that value of x into the equation that has the positive y's. You could do it into the one with the negative y's, but it's easier to do it the one with positive y's. Then that new equation that we get, we solve for y, and then we can check our result in the next equation. So here's an example for us to try. We can see it's type 1 because we've got positive 4y's and negative 4y's, so we've got the same number but different signs. I've put the steps that we go through on the right hand side of the screen. So the first thing we do is we're going to label the equations. That's just good practice. So we add them together. So we're going to say 1 plus 2 to tell the reader what we're doing. So we've got 5x's plus 3x is 8x, the y's cancel, and 6 plus 10 is 16. So we now solve for x. We've got x equals 2. We're now going to substitute that into the equation with a positive number of y's, which is going to be the first equation. So instead of 5x's, it's 5 2's. So we end up with 10 plus 4y equals 6. Well, if we take 10 away from both sides, we get 4y equals minus 4. Divide both sides by 4, and we get y equals minus 1. So the solution is x is 2, y is minus 1, which we can show as a pair of coordinates. Well, why do we do it like that? Well, let's look at what we've got here. We've got our 2 equations, 5x plus 4y equals 6, and 3x minus 4y equals 10 that we had before. Well, they're both equations of lines. So let's draw the first line, 5x plus 4y equals 6, and we get that line going down there. Now let's draw the next line, 3x minus 4y equals 10. And let's look at the point where they intersect each other, and that's the coordinates 2 minus 1, which, if you remember, was the solution to the simultaneous equations that we solved previously. So we could consider the solution of a pair of simultaneous equations as being the point of intersection of the lines. Here's one for you to try. You can see it's type 1. We've got the same number of y's, 1 in this case, and the signs are different. I've got the steps on the right hand side for you to follow. I would do this, but pause the video and see how you do, and you can check it against the solution that I give you just after this. So pause the video. Okay, how did you do? Well, hopefully you added the equations together to get 5x equals 35 and solved that to get x equals 7. You substituted into the equation with a positive number of y's, so instead of 4 x's you got 4 7's, which is 28 plus y equals 25. You took away 28 from both sides to get y equals minus 3. That means that these 2 lines intersect at the point 7 minus 3. I've actually put a worksheet, a link to a worksheet in the description below. If you click on that, you've got some questions that you can try on your own. I hope you found this tutorial helpful. Stay in infield with Winfield.